Okay, in what I believe is my final video of the year, let's do unit test number 4 and unit test number 5 trig related stuff for review. Okay, so this summative exam review day 4. So start off with drawing angles. Don't forget that 0 to 90 here. So we go 0. So these are some of the things 0 to 90 here. 90 to 180 is in this quadrant, quadrant 2. 180. This pen's acting funny. Hold on. Let me see what I can do with this. 180 to 270 in quadrant 3. 270 to 360 in this quadrant. Remember, quadrant 1, 2, 3, 4. There'll be other things we're going to add in a bit. So first guy here is negative 55. Remember, positive 55 would be rotating this way. Negative is rotating this way. So you go down less than 90 degrees here. And if you want to get the related angle in the the principal angle, sorry, we'll get to that in a second. Here, 403. Where does that end up? Actually, let's go to the principal angles first. If you want to know, principal angles is the angle that's related to these angles here that is between 0 and 360. So that fits in here. And to get this from negative 55, what you do is you add 360 and you end up with 305. So 305 would be in this quadrant here, quadrant 4. So you could draw it like this and say this is 305. It's the same thing. Okay, so these are called related angles. Sorry, coterminal angles, I'm sorry. And if I want another one, I could add another 360 here, and I could end up with 665. The other thing is I could subtract. So if I have 55, I can subtract 360, and I end up with negative 405. The principal angle, like I said, is the one between 0 and 360. Here I have 403. If I go 403, which is more than 360, and subtract 360, I end up with 43 degrees. 43 degrees is less than 90, quadrant 1. That's why I drew this. 403 and 43, just a coincidence that they look similar. And the next one will be 763. That's adding 360 to 403. I end up with 763. This guy is the principal angle because it's less than 360. It's the one that makes the most sense. Okay, if I want to look here, determine these values here, no calculators. The cosine of 120. All right, so remember this cast law. Start off with a cast law. First of all, the cosine of 120. 120 is in this quadrant here, quadrant 2. Only sine is positive in this quadrant. Therefore, the cosine of 120 will be negative. I find out. I have our table. You have the table from your equation from your formula sheet. It says there that it has all the related angles, but the related angles are less than 90 or 90 or less. So I have to find the related angle in quadrant 1. To get to quadrant 1, remember we have theta. 180 minus theta, 180 plus theta, and 360 minus theta. I'm in quadrant 2, so 180 minus theta is equal to 120, which is the angle I have here. 180, so I solve theta is 60. Use my table. Cosine of 60 is a half, but since I'm in quadrant 2 here, cosine of 60 is a half. Quadrant 2 says that my sign is negative for cos, but 60 is related to 120, so the value of 1/2 comes from here, from right here. The sign comes from the fact that we're in quadrant 2. Okay, here I want the cotangent of 225, which I'm not really going to do. What I really want is 1 over the tangent of 225. Okay, so we don't have, on our tables, we don't have cotangent, cosecant, and secant. We only have the three principal, the three major ones, relations, sine, cosine, and tan. And so I want the tan 1 over tan 225. So let's figure out what tan 225 is. 225 is in quadrant 3. So back to here, cast law says quadrant 3, 1, 2, 3, tan is positive. So my final answer is going to be positive. So I want tan 225. It's related to, let's find out what it's related to. 180 plus theta is 225 because I'm in quadrant 3. I use this 180 plus theta. It's 45. I'm related to 45 degrees. Tan of 45 is actually 1 for my table. And so then the tan of 225 is positive 1 also. Okay, don't change the sign, don't change the number. So I'm still at plus 1. And then the cotangent of 225 is 1 over 1, which also happens to be 1. So a lot of coincidences here that we have 1, but that's how you find that. Okay. So after that, let's move on. Solve for two values of theta to the nearest degree, blah, blah, blah. So this, grab your calculator. Okay, so first of all, I have a negative cos value. So I'll rewrite this here because you can't see it anymore. I have a negative cos value, so I know that positive is here and here for cos. That's a T. Here and here. So my negatives are in quadrant 2 and quadrant 3. I don't throw this in the calculator, okay? What you want to do is throw the get rid of the negative and throw that in the calculator and find the related angle in the first quadrant. if you put in a negative in, you're going to get different answers here. Okay, you might get the answer in the fourth quadrant, in this quadrant. You might work it out, but either way, we're going to have to take our answer in the first quadrant and move it to the second quadrant and the third quadrant. Okay, so get rid of the negative, find theta. Cos theta is this. Second function cos of 0.1683 gives me 80 degrees. 80 degrees in quadrant 2. 180 subtract theta is 100. 180 plus theta for quadrant 3 is 260, and those are my two answers. Okay, cosecant theta is this 1 point. I don't know if you have this, but change it to 1.3729. So I'm not going to find that. What I really want to find is sine of this. Sine is positive. Sine is positive in quadrant 1 and quadrant 2. So let's do this in red here. Quadrant 1 and quadrant 2, I have positive signs. So my answers, I'm looking for 1 and 2. Sine of theta is this. So I put this in the calculator, 1 over 1.03729 second function sine button. And I find theta is 47. That's my quadrant 1 answer. Quadrant 2, move it there. 180 minus theta gets me that. So 180 minus theta from over here. Secant, this is from the table. Secant is root 2. Again, I don't want that. I want cosine. Remember, cosine goes with secant. So remember, cosine goes with secant. C with S, S with C. Sine with cosecant. Cosine with secant. And tangent goes with cotangent. Okay, so it's cotangent here. Secant and cosecant. Sine, cos, and tan. Okay, so I want this. Okay, it's positive cos, and again, sorry, we had negative cos. So positive cos. Let's do this in black. Positive cos, everything is positive in 1. Cos is positive in 4. So I'm 1 and 4. I look at my chart. This is in the chart. If you see root 2 and that sort of thing, check the chart out. If not, if you threw it in a calculator, you get the same answer. In Q1, my answer is 45. And then I have to move it to Q4. So 360 minus 45 is 315 degrees. Okay, keep going. Center position, 3, 3. So this video is going to be quick. I might have to do 2 here. We'll find out. Blah, blah, blah. So let's find out sine and cotangent here. So don't forget, so P is, there's my X value and my Y value. So that's 3, negative 4. So 3, negative 4, I end up down here. And I want to find out what else is going on here. So remember X, Y, and R. This is X, Y, R. R is the length of this line. So here's X, here's Y, and I want to find R. And we have sine is equal to, you have this on your sheet, y over r, cos is equal to x over r, and tan is equal to y over x. So then we're going to figure things out here. So let's find out r. Remember, we use Pythagorean theorem here to find out r is the square root of 3 squared plus negative 4 squared. Figure out that's 5. So now that's r, x 3, y negative 4, r equals 5. And then sine is y over r. That's great. I have that. And cotangent. So it says here, find the cotangent. Well, it's 1 over tan. If tan is y over x, which we have in our sheet, 1 over is the reciprocal of this too, so x over y. So you go x over y, 3 over negative 4, and that's it. And then you look back here, I said Q4, therefore sine and cotangent. If I'm in, sorry, this is in quadrant 4, and then this answer was negative, this answer is negative, and that's nice because Cast law says that tangent or cotangent is negative here. Only cosine is positive here, sorry. So if cosine is positive here, then sine is negative, and cotangent or tangent is also negative. Next, trig. Okay, there's your triangle. I want to find out this little x here. Okay, so I have my answer. I'm confusing myself here. So here, cosine law applies because I have 2 times use cosine law is when you have 3 sides or 2 sides in the contained angle, and that's what I have here. So I set up cosine law like this. I move across and I find A by using cosine law. Okay, so there's the equation for you. You figure out, plug it in, and work from there. Now I have A, which is 2.9. So this is 2.9. So now let me just redraw this. Something like that. Sorry, that's a triangle. So that's 49. That's 80. If that's 80, then you know this is 100. Okay, because this is a straight line. So that's 80. That's 100. So that's 100 here. 2.9 here. I have this pair here. I want this here. So see this here. This is a pair here. I want to find out what x is. So if I want to find out what x is, I write. Remember how we set this up is I write what I'm looking for first. So I write little x. This is little x here. X over sine x is equal to a over sine a. I made this a and a. That's a big X. That's little x. So what goes here is what I'm looking for. It goes over sine of the angle, and it's equal to, nice and symmetrical, little letter here, big letter here, big letter here, big letter here. remember, anytime you have a big letter, so even here when you set this up, if you set this up that way, anytime you have a big letter, that's an angle, you need a sine or a cosine in front of it, a cosine up here or a sine down here. One move, okay, sub in, and then one move, bring your sign up and solve for x. Triangle here, this is the ambiguous case. Okay, I don't think I told you this here, but it is the ambiguous case. You set it up like this. Whenever you want two possible answers, that's what you're looking for, ambiguous case. Okay, ambiguous case. You set up the triangle like this, just the way you would normally. And the thing is, that works, but then when you shift it over, you end up with something like this. So this stays the same, and then you bring this guy over from here to here, and he ends up making a triangle here. So this is gone. So I have two different triangles, both with 3.6 and 3.1 as my side lengths and 50 as this contained angle here. So you do the whole thing, you set it up like this with sine law, you solve it, and only difference you do, you move this up here and you solve, and you get 74 degrees, and that's your answer in quadrant 1. And there's a second answer. All you do is take your answer from here and subtract it from 180 and get the answer in quadrant 2. Cast law also helps out. Sine is positive here and sine is positive here. So here you have a sine that is positive, and you want to find in quadrant 2, it's also positive in quadrant 2, and you just go 180, subtract it. Okay, so I'm going to call it quits on this video. I'm going to have to do another one for test